loud noise, saw flames, and ran for safety.
Don't think you'll be needing that umbrella.
You never know.
They live a life others only dream of. No limits, no boundaries.
What? You think you're the only one?
But their freedom comes with a price.
There's something you're not telling me. If you don't want to tell me everything, that's fine. Just don't lie to me.
You think you can jump all over the place and nothing's gonna happen? But they've noticed.
Don't run. I just want to ask you some questions. You think you could go on like this forever? Living like this with no consequences? There are always consequences.
What did you tell him? What did you tell him? What happened to the war?
Take a deep breath.
It's not as easy as it looks.
The intermediate value theorem is not like jumper at all. You have to go from one place and walk to another. You can't just hop from one to another. So IVT shows you that path. The intermediate value theorem states that a function is continuous on a closed interval from points A to B, then it takes on every value between those endpoints. So along this whole line, takes all the values from point A to point B. What this statement below means is that if a function is continuous on a closed interval from A to B, so from here to here, and k is between A and B, so if k is somewhere in between this line from A to B, then there's at least one c in A to B. So this k is somewhere in between this line from A to B, and C is where it is intercepted. This question tells us the measurements of a bike riding on a road on the interval from 0 to 20. Here's a table with information about the bike and a graph that shows that box. So the first question asks, must there be a time where BT equals 2.5, and to justify your answer. So what we need to do is take a look at our little chart and see if there could have been a time where it equals 2.5. From 3.3 to 4.2, the bike never reached 2.5 exactly. And from 4.2 to 2.7, it didn't reach the 2.5 either. But from 7 to 9, the bike went from 2.7 to 2.3, and that passes 2.5. So yes, it did pass 2.5. So yes, and we justify our answer by saying IVT. The next question says, must there be a time where VT equals 5? And if you look at this chart up here, the max speed is 4.6. So this chart may have looked like this, or it may have looked different. It could have gone all the way to 5 and slowed back down, but all you need to know is that the top speed on the chart is 4.6, and you're not sure if it went to 5, but it didn't have to go to 5. So that's the key. So the answer is no. And once again, IVT for justify your answer. For the last question, what is the least number of times where VT is exactly 4 meters per second? Once again, look at the chart and see where it passes 4 meters per second exactly. So from 3.3 to 4.2, it had to pass 4 at some point. So that's 1. 4.2 to 2.7 had to pass it again. 2. 2.7 to 2.3 didn't. 2.3 to 3.8 it didn't. But 3.8 to 4.6 it did. So that's 1, 2, 3 times at least it had to pass. So 3 times, and once again, IVT.